Hello, my name is Abby, and my partners for this project were Ty and Michael. For this project, we will be looking into the wait times at UFood Grill at Liberty University. The wait times at UFood Grill are higher than acceptable for most food places, let alone a food place on campus. We plan to conduct a time study, analyze the results, and see how it can be changed. Our hypothesis is that the average wait time during the busy times is 5 minutes, and the average wait time during the relaxed times is 2 minutes.
In order to begin this project, we needed to assess what our project included. This was discussed in our project scope. We first defined the goal of our project. Our main goal for this project is to decrease the total time spent ordering and waiting to receive food at UFood Grill. Our deliverables for this project are an outlined course of action in order to accomplish our goal and the analysis of data measured that is necessary to quantify times taken at the restaurant. Our plan is to define our problem, which is directly related to our goal statement. Then, we need to figure out a course of action in order to address the problem. Next, we will acquire and analyze data and compare that against our hypothesis. This all needs to be completed by April 22nd, while our paper was completed on March 13th, as the presentation is due March 25th.
DMAIC stands for Define, Measure, Analyze, Improve, and Control. In regards to our project, we will define the problem, which is the wait times at UFood Grill. We will measure the time it takes for customers to get through the line and to receive their food. We will analyze the results to see where the bottlenecks are. We will try to improve the wait times by suggesting that they hire another person, purchase another oven, or change the layout. We will see that our improvements are under control by conducting more time studies and asking the workers how they feel about the changes.
For the solution to our problem, we propose two options. The first option is to hire another worker to work on the fry station, or the second option is to purchase another oven to keep up with the speed of the order. For the first option of hiring another worker, even though we do not know the exact wage of a Sodexo worker, we believe that $8 per hour is a pretty fair estimate. And as you can see, this is the table calculating the cost to hire another worker, and per 1 year we'll have to spend $10,240 for an extra worker. On the other hand, this is the cost to purchase another oven, and even though we don't know the exact model that UFood is using, we found out that the cost of a mid-range restaurant oven is about $2,000 to $3,000, and we chose an industrial oven with the MSRP of $2,400. And after researching, we found out that the lifespan of one of those oven is about 15 to 20 years. So this is the table of each year cost based on how long the oven will be usable. Even though the $2,400 might be a big initial investment, the cost for each year gets significantly lower and lower, and it goes down below the $100 mark per year after 12 years. And if we compare the two options, the option of purchasing an oven is far more superior in terms of cost, with the earliest lifespan, earliest predicted year of lifespan is 15, which results in $75.54 per year, comparing to $10,240 per year, which is a more than 10,000% increase/decrease. Next, we'll move on to the MARR portion, and like most companies, we're going to use the 12% hurdle rate for our minimum acceptable rate of return, and for our calculations, we're only going to use the meal swipe option that the restaurant is offering, because from our time study, that option makes up more than 80% of the order. And for the option 1, which is to hire another worker, with the MARR of 12%, the restaurant needs to sell 11 extra meal swipes per day to reach that. And this is certainly doable, as the dedicated worker would speed up the process and attracts more students to eat at UFood in busy time. In the right corner, this is the table showing the calculations with the MARR of 12% and the interest rate of 10%. As we can see, even if the oven only lasts 1 year, the restaurant only needs to sell 3 extra meals per day to reach the 12% MARR. And if the oven lasts more than 12 years, UFood basically only needs to sell 10 extra meal swipe per semester, which is a very feasible goal considering how many students the restaurant will attract with much shorter times because there's one more oven. Finally, we'll take a look at the expected return. And this portion of the proposal consists mostly of speculations based on the number of students observed during our time study and the overall mindset of if I do not have to wait a long time to get food, then maybe I'll go to UFood. To produce a scientifically correct result of the expected return, extensive studies of daily average improvement in serving time, if one of the option is implemented, as well as surveys need to be conducted. And since we did not have the time to conduct all those studies and surveys, we can only base our projections on the data that we gathered with our time studies. And with the baseline of 60 customer increment per day, we'll have the expected return of 62,400 for both options per year, which is a 609% return percentage with the first option and 2600% with the second option.
When we first began our data collection, we first had to decide when we would time our participants. We split up our data collection time periods into 2 different categories: peak times and control times. We decided to begin our measurements at those 2 time periods. We then had to define how we were going to measure the data. We decided that we would measure ordering time as the time from when the individual entered the restaurant to when the individual received their receipt. We then started the second timer that would define the wait time. The wait time began when the individual received their receipt and ended when the individual received their food. Our Thursday data collection began as one of our control times. We consider it a control time because it is not a busy time of day, but a steady business time. This time sees many fluctuations in wait time and order time in a seemingly random pattern. Although some of the times were very high, our average combined total time in the restaurant was around 3 minutes. At our peak times, however, we had very different results. Our peak time was chosen as a time that is both between classes and near lunch, when most students would be able to grab lunch. At this time, the average customer spent over 12 minutes in the restaurant. This is 4 times higher than our control times. We saw that this is a problem, and customers were visibly frustrated at the lack of prompt service.
This is the mind map of our project. From the center, we want to have shorter wait times. Stemming from this are 2 problems that affect the wait times: the layout and unfries. On the unfries side, it can be solved by hiring another person, purchasing another oven, or doing both. On the layout side, this problem can be solved by changing the layout of the counter, changing the layout of the line, or doing both. Thank you for watching.